This video is a quick review on how you can classify a system of linear equations. First off, we have a system of linear equations. You have two equations where they could either intersect at one point, they could be the exact same line, so one line on top of another, or the lines are parallel, which means they never cross. Now, how does that affect the equations? Well, if the two lines cross, their slopes are different. If they are the exact same line, the lines have the same slope and the same y-intercept. And if the equations do not cross each other, that means they have the same slope, but their y-intercepts would be different. Now, the solutions. For a system of equations, if they cross exactly once, we have one solution. If they are one line on top of another, you have infinitely many solutions. That means every solution would work. And if the lines never cross, there is no solution. So how would we classify these? We would classify them, if they cross, they would be consistent. So the one on the left, they cross exactly once. So this system is considered consistent because there's at least one solution, and it's independent because it has exactly one solution. So one way I think about it is you have two separate lines that cross once, consistent and independent. The middle one, it's the exact same line. So this is consistent because they do cross. It's dependent because there's infinitely many solutions. They are the exact same line. And the third example is inconsistent because the system has no solution. They don't cross at all. So let's take a look at some examples. We're going to determine the number of solutions the system has and then state whether the system of equations is consistent or inconsistent. And if you say it's consistent, then you have to write as if it's independent or dependent. Now, one way of doing these, to determine if these will cross, is the first thing I would do is put them into y equals mx plus b. So this first one on the left, I'm going to divide everything by 2. And when I divide everything by 2, this one has the equation of y equals 3x minus 7. The one on the right, if I want to get y by itself, I'm just going to add y to both sides. And then I'm going to subtract the 7 on both sides. That means I have y equals, and I have 3x minus 7. Now if you notice, the slopes are the same and the y-intercepts are the same. So that tells us this is consistent because they will cross. And I know that they will cross because the slopes and the y-intercepts are the same. So then I would have consistent and dependent. It's dependent because they are the same exact line. And one more example. Actually, there's two examples here. And going back to the other one, I forgot to say that this one has many solutions. Now our last two examples. Okay, so we're going to put it into y equals mx plus b so we can determine the slope and if the y-intercepts are the same. So this top one, I'm just going to divide everything by 2 to get y by itself. And that's going to give me y equals, I'm going to put the slope first, so that's a negative 8x plus 4. And the second one here, I'm going to subtract 24x on both sides. That leaves me with 3y equals a negative 24x plus 21. Divide everything by 3. And I would have y equals a negative 8x plus 7. Now, because the slopes are the same, but the y-intercepts are different, I know these are just two lines that are parallel. So that means there's zero solutions. And because it's zero solutions, they are inconsistent. And the second example here. Here I'm going to get this in y equals mx plus b. So I'm going to subtract 4x on both sides. And that's going to give me a negative 5y equaling a negative 4x minus 35. Going to divide by negative 5 on both sides. And I have an equation that's y equals positive 4/5 x minus 7. And this other one, I'm going to add 9x to both sides. This is going to give me 10y equals 9x plus 60. Going to divide this by 10. And I would have y equals 9/10 x plus 6. Now, since the slopes are different, that means I'm going to have one solution. And this is consistent because it crosses. It has one solution, and this would be independent because it has only one exact solution. So as a quick review on how you can classify systems of linear equations.